Alrighty. Good morning, everybody. Good morning. All right. Well, welcome to Material Science 2010 or MSE 2010 or MatSen 2010. This is the intro class, so if you weren't looking for this class, now is your time to exit. As you can see also on the slide, here's all the information. You should have received an email from me yesterday. If so, great. That's how a lot of our announcements are going to be sent, in addition to just the general announcement through Carmen. If you didn't get an email from me, please let me know after the class or via email. Okay, we'll just start off with very quick intros because some folks have to leave. All right, so myself, I am the one of the two instructor of record for this class. You may have seen on the registrar it being listed as Vicki Dawn Nguyen. That is my married name. My professional name is Vicki Dawn Nguyen. I will answer to Dr. Dawn Nguyen, Professor Dawn Nguyen. Really, you have a lot of choices. My pronouns of choice is she, hers, and hers. My office hours are going to be in Watts 494, and of course, that's my email. I'm also in the OSU registrar system, so you can look me up there as well. Before he has to go, let me also introduce you to Dr. Brown.
Hi, everyone. So I'm Dr. Brown. I am the course coordinator for this course, which means that I'm your point of contact for administrative type things. If you have questions about Carmen, if you have questions about your grade, if the homework, I'm going to be posting the homework, so if you have like administrative type questions about the homework, you would come to me. I'm also a material science PhD, so I'll also be able to help you out with homework if you can't get help with recitation or through the TAs or whatever. I have office hours, as you can see, Watts 482 on Thursday afternoons. So, yeah.
Yeah, and I'll post that in a little bit.
And my email is browndup4972. And so I have to run to another class, but.
All right, double duty. Great, okay. So we are your two instructors, but we also have a fabulous TA team. All of these slides are posted, so you don't have to write down any of these email. Of course, they're also listed on Carmen. But one of our TAs is here, Tony is here. All right, so our team is very good. They're very responsive. These are senior undergraduate students who have done very well in the class, or they are graduate students, some of them second year, some of them third year, and so they're very knowledgeable in the introductory material. They're friendly humans, so you may approach them and ask all of your questions, and of course, your instructors are also friendly humans who, with mutual respect, will also answer your questions. So anyway, those are all the contact information. Now, to navigate this course, this is the slide. If you have any questions, how do I streamline my questions so that it gets answered in an efficient and timely manner? This is the lay of the land right here. So if you have homework questions, as Dr. Brown has said, he will be taking care of all of that. Also, we're using a program called Wiley Plus. This is different from previous years. This is the second semester implementation. It is a new program. We've switched textbooks. You may or may not know if you talk to somebody who's taken this class last semester or 2 semesters ago or like 10 years ago. It's a different textbook. Okay. There are several main textbooks for material science. This is one of them. We've made choices based on student feedback and also the features that come with the textbook. Okay, so this is not something we've made, this is not a decision that we made in passing. We've talked with the representatives. We made this decision with a lot of consideration from many people, okay? And so this, we think, will be the best learning experience. But of course, everything is always evolving, so this may change in a few semesters, who knows? But for now, this is the best one that we're going with. In terms of lecture, we do have in-class activities, in-class questions, and so how I administer that is through Top Hat. Attendance is not part of your grade, but a lot of you, and we'll go over the exact statistics, a lot of you are upper class people, and so you probably have realized that showing up to class, even though the lectures may be recorded and posted, here is another 50, 55 minutes for you to get your questions answered and for you to dedicate this time to really absorb the material. A lot of you are not in the major, so a lot of the information may be new to you. Even if you're in the major or pre-major, a lot of the information might be new to you, and so this is just another opportunity to absorb that material and discuss it, during the in-class activities with your colleagues. But if you have any glitches, our fantastic TA, Brian, will be taking care of that. So someone just notified me that they can't log in through a particular device. Honestly, sometimes, did you press off and on? I know it's a silly solution, but let me tell you my number of years of experience. Did you jiggle the cable and did you turn it off and on? Works quite well. If that doesn't work, Top Hat help. They're very responsive, and so you can contact them, because sometimes we can try to give you all the solutions, but they can also just log on and deal with whatever it is that is particular to your account. So it might be faster. But if you're already at office hours or you want to shoot an email to your TA, fine by me. Excuse me. I'm getting over a cold, so excuse the throat clearing for now. In terms of recitations on Top Hat, attendance will be taken during your recitations section, because that helps us track your progress. Once again, it is not part of your grade, because you are upper class people and you know how to manage your time at this point, so we're not going to force you to come to attendance. But once again, statistics have shown that if you participate, you generally do better, and it is another opportunity to ask questions, have discussions, and if you're doing exceedingly well, it's another opportunity for you to pat yourself on the back, because you're getting all of the material already. Discussion forums. I think a lot of you have already had large lecture courses, right? If you have a question, that means your colleague probably, there's at least one other person with the same general question, unless obviously it's something very specific and private. Send us an email. But if it's a general topical question about the material, we want to announce the answer or solution or general strategy for solving that kind of problem to everyone. So if you email us personally, we'll reroute you to the discussion forum, or we'll repost your question to the discussion forum with the solution, so that everybody has the same information. We try to be as transparent as possible, unless, of course, it warrants some privacy, like medical conditions, all that. So you can email your TAs about that as a first step. Well, one, attend your recitation, because it'll probably be a practice problem during recitation already. If it's a complex problem, we probably will have selected that. If you want to generally discuss some concepts, get some feedback on if you're thinking about a problem in a reasonable way, attend office hours in addition to a recitation. And then, of course, you can also email. If I know there's 191 students enrolled, we have some office hours, but that might not be amenable to everyone, and we realize that. And in terms of administrative issues, what Dr. Brown has said holds true. To streamline all of your requests, this morning we received all the SDLDS requests. We just got them, so we will be processing them. And by we, I mean Dr. Brown. He will efficiently go through all the requests, and if you need follow-up in terms of extensions, all of that, that will be done. But to streamline it, only one person does it, and that's going to be Dr. Brown. If you email it to me, what will happen is I'll probably just hit forward, CC you, and then that gets taken care of, okay? And then, of course, exams, you need to make them up for whatever reason. You can't control if you get the flu 10 minutes before, right? So please email us, notify us in some sort of way as soon as possible, so that Dr. Brown can scheduled the makeup exam for you. And of course, we understand some of you are scholar athletes, some of you have military duty, some of you have family events that have already been planned for many months. We understand everybody has their own schedule, so please let us know if you need accommodations well in advance, and definitely not after the fact, okay? Okay, this is posted on your syllabus page, so if you can't read the smaller type font size, you can zoom in on Carmen. Here is the schedule Monday to Friday for this class. So you see all of the lectures in yellow, the recitation sections in green, office hours in orange, and there's only one red rectangle that have been outlined on this schedule, and you can see that your homework is due at 5 p.m. and there is some penalty if it's turned in late. I should also note that there is no curving in this class, okay? And when we assign grades, it's really by the OSU system. There's no additional points for effort or anything like that, you know. But I will say there are curving features built in. What does that mean? For your homework, it is 35% of your grade. So it is actually a substantial part of your grade because we would like for you to practice, you know, problem solving and understanding all these concepts. The curving that's built in is that we give you unlimited chances to try to get the right answer. So if by the 5th time it's not working, it could be that you're outside the tolerance factors for what's acceptable for the answer. Please see your TA for that, or go to office hours. If you know, it's your 5th time and you're like, you know, this methodology that I'm trying is not working out, here's your chance to, you know, it doesn't have to be your 5th chance, but you know, you can post to the discussion forum. You should check the discussion forum to see if that question has already been posted, and that might give you a strategy to go forward. Okay, so that's how the curving is built, and we want you to try and get the right answer and seek help if you need it. Okay, the other curving feature that is built in already is that one of your homework assignments will be dropped. So once the semester is over, we take the lowest score of one of your homework assignments and we just drop it. And then there will be 10 assignments, and that is your homework score. And that's updated through Wiley Plus, which is seamlessly integrated to Carmen. So you should see in real time, you know, every time you hit submit on your homework, it should already reflect in your grade. Okay, so that way, by the end of the semester, whatever comes out, the curving has already been built in, okay? And as you notice with the orange office hours, we try to distribute it throughout the week and throughout the day so that we can try to catch as many people as possible. So if you're an early riser, maybe 8 a.m. office hours could be for you. If you have classes up until 5, we do have several options for that. And then, of course, there are office hours in the middle of the day as well, because sometimes, you know, you have that few minutes, you want to stop by. If you're going to a TA office hours, you'll notice that they're all in 479. That is the Watts Hall student lounge area on the 4th floor. And you should see a lot of people there, so it should be obvious where it is. In terms of recitations, as I mentioned, they're facilitated by your TAs. There will be some worksheets to sort of kick off the discussion. Your TA will also be doing some practice problems that are select homework questions. And of course, if you cannot come to any of the office hours or whatever it is, or if you need to switch a section for that week because you have to be elsewhere, please let your TA know, and then CC the other TA for the section that you're going to so that they know to accommodate you. We make physical copies of the worksheets for you, so you don't have to print it out. And we try to make a few extra, but of course we can't always predict influxes and such. So if there's a lot of you all of a sudden needing to go into another section, that might be okay if the room can physically accommodate you. But on top of that, your TA should also, the new TA should also know, so that they know to plan accordingly, especially if they have group activities. They need to just know. Okay, this is in your syllabus. It is also posted on the Syllabus Carmen site. It outlines every single lecture for the semester and what we will be covering. If there's any modification, you will be alerted. Do not fret. So if we need to extend a lecture by half of a lecture to answer all of your questions, or go into greater detail, something that is a sticking point for a lot of you, that will be notified. Lectures will be uploaded ahead of time so that you have that in your notes for your note-taking, and that will be uploaded to each module on Carmen. The lectures will also be recorded and posted within 24, 48 hours of each lecture. It's a little bit blurry, mainly because I took a screenshot, but the full resolution is on Carmen. So you'll also note that there are 2 exams and a cumulative exam. Those are highlighted in yellow. We will also be sending out reminders so that you know it's coming, but it's there, and it will be on Carmen calendar as well. So you can see we're going to try to cover a lot. This is an intro class. For your homework, it will be specified which sections are included and which sections are not included. So you'll see that homework 1 covers chapters 2 and 3. Homework 2 covers chapters 3 and 4. So we've divided up because I can't cover all of chapter 3 in time for the first homework. So it will be very clearly delineated which sections will be covered and which sections will not. And if you've already checked out the Carmen page, you should see that homework 1 is already posted, and you should see that it ends on section 3.12. Okay. So please take a note. Put it in your calendar. Okay. And if you have any family events, we've been notified of the athletic events. We'll notify you if it happens to correspond with an exam date. But please also remind us and just make sure that your request has already been submitted so that you can take the exam at a later time, or earlier, or in another location. As I mentioned, also in your syllabus, this is your grade distribution. We try not to overly test you, but at the same time, for ABET accreditation, we sort of have to prove that you've learned something. So that is resulting in 2 exams and a cumulative final exam. Your homework is a huge portion of your grade. So we try to open it 2 weeks in advance so that you have ample opportunity to ask questions, or just honestly make adjustments in your schedule so that you can just get it done. Okay, any questions thus far on the administration? Pretty straightforward. There's a lot of you, so we try to streamline this so it's quite transparent and that there aren't a lot of hiccups. Okay. Since very few of you are actually pre-majors, you may have not thought about what is it material science and what is it, why are you actually here? I do know that a lot of you, this is a required class, so maybe it's just something that's required for you to take. But it's actually quite a rich field, and it involves understanding synthesis, developing synthesis of materials, and then once you've made a material, how do you know you made what you made? Right, so we have characterization techniques. Some of you, if you've done research, or maybe you co-opt in industry or worked in another lab within academia or outside of academia, maybe you've utilized some of these techniques already, but we'll talk about different ways of characterizing the material. And so we'll get back to what actually is a material, because isn't that everything? And the answer is yes, it is everything. we spend a lot of time thinking about structure of materials as well. Not just structural materials, will this beam hold up this bridge, but beyond that, we think about if I start off and choose a material that has a certain type of crystal structure, if I know how the atoms pack within a material, can I predictively go towards the end and predict its properties? And a lot of the times the answer is yes. Would I choose something that is hexagonally close packed versus face-centered cubic, right? Would I choose magnesium over aluminum, that sort of thing? Beyond lightweighting, beyond other properties, can I think about a material structure and then predict the property? And that's a huge area of which that a lot of people study. And of course, performance. Once you've chosen a material, how does it perform over time, right? Some materials, you want it to last for all of eternity, right? Some materials, you don't want that. If you take a pill capsule, you don't want that plastic coating in your body for long, extended periods of time. You actually want it to biodegrade, right? So depending on what performance you're aiming for, you're going to choose your material wisely, okay? So that's what we also study. How does a material perform over time for which we need it for? And processing, what's the best way of processing a material? And it's not just, well, what is best, right? Is it just the least expensive way, the most, I guess, energy efficient? Will it produce a lot of CO2? Let's see. Okay, and then of course, all of that gets wrapped up in the properties, right? So that is the tetrahedron that a lot of material scientists use to basically describe what material science and engineering entails. It's one of the few fields where there's a science and an engineering component in it. So there's fundamental research that gets done, and then there's also applied research that gets done, and we cover the gamut. Okay. So I mentioned all of these questions that we ask when we think about a materials problem. Okay. Some of the properties that we'll be going over in this class are listed here. And we'll go over 3 broad classes of materials, metals, polymers, and ceramics. There are other types of materials, if you can call them that. They're emergent materials. So what does that mean? They have properties that are different from what are the classical type materials. So metals, right? So gold is a metal, but a lot of you have heard of nano gold, maybe. Carbon is a material, diamond, right? Graphite. But when you nanostructure a material, it could potentially have emergent properties or different nanostructured properties that don't exist in the bulk structure. So gold metal in the bulk does not necessarily have the same properties as, let's say, a few thousand atom cluster of gold, right? And it has drastically different properties to the point where, catalytic converters, if you use platinum, another metal, if you use bulk platinum, it wouldn't have the same effect as if you use nanostructured platinum. So your catalytic converters in your cars use nanostructured platinum, and so even though you have a nanometer or 2 of platinum, it reacts way better and is way more efficient at converting CO to CO2 so that your car meets emission standards than if you use bulk platinum. So yes, platinum is a metal, but nanostructured platinum is different. And so we'll talk about nanomaterials as sort of a different subgroup or different type of material later on. But for the majority of this class, we'll be focusing on the classical bulk type properties of metals, polymers, and ceramics, because this is an intro class. Obviously, if you'd like to continue learning more about specific classes of materials like nanomaterials or metamaterials and all of that, there are additional advanced classes that you can take. And since the majority of this class are mechanical engineering students, this might be a breeze for you, in which case, congratulations. It will be a great review for you. Textbooks. Can you succeed? I get this question almost every semester. Actually, I think, yes, every semester. Can I succeed without the textbook? Can you succeed in general in life without anything? Probably. You're humans. But will it be helpful? Yes. And there's a reason why we selected this textbook. Okay? We think it is helpful, and it does come with resources that I think will be useful for some of you. And there are different features. Not everybody learns in the same way each semester. Maybe you evolve by semester, and the way you learn something one semester might not be the same as the next semester. But there are tutorials, there are video supplements that will work out different strategies for solving problems. So will it be helpful to get the textbook? Yes. And also it's tied to Wiley plus your homework. So it is actually very helpful. Okay. As I mentioned, Top Hat. So today we were going to try to work out some quirks for Top Hat. So depending on whether or not I can log on to my own Top Hat, we can execute that. But all the questions on Top Hat will also be logged so that if you would like to use them as a review for the exam, they'll be there as an added resource for you. So with that, let me switch over. One moment. Okay, so this is just a practice question. There is a timer. All right, so you should, there's a 2-minute timer, but that's just the default. So this is your chance to make sure that your devices work, and if not, please let us know. So the question is, which of these materials produce the largest amount of carbon dioxide as a byproduct? It's worded a little differently on your Carmen slide deck. The alternative question is, production of which of the following materials emits the largest amount of carbon dioxide as a byproduct? And your choices are cement, A, B, carbon nanotubes, C, aluminum foil, D, polyethylene terephthalate, or PET water bottles, or E, wood. You may confer with your proximal colleagues. All right, about 12 seconds. Let me know if people are having a hard time logging in and need a little bit more time. Okay, so thoughts? General murmurs. Sounded exciting or confused. It's hard to know. I don't have anything to calibrate just yet. Okay, let's see the answer. Ah, interesting. Okay, for the for the 13% that answered correctly, does any one of you know the actual amount that's put out? Or did you just guess it because it was A? How is this measured? It's just by the total aggregate of material that's produced. So you could tell that the way the question, which is, thank you, what's your name? Jacob. All right, so Jacob asked a clarifying question, which is, how is this measured? It's measured by a report that was put out by the World Economic Forum, but How is it measured? So wood, is it the growing of the trees and then cutting down of the trees and all that? No, I just put it there. No, cement, how is it measured? It's by the sheer amount that's produced. If you think about it, how many tons of cement is produced or produce? A lot. It's billions of tons. Cement is everywhere. It is what you don't think about until there's a crack, and then you trip on it and you say, oh, there's a crack in the cement. And then you realize there's a lot of cement around you. We have major cities that just have cement everywhere. And the production, the silicate production, the process itself produces a lot of CO2. So if you can make a dent in making this ceramic more efficient in terms of producing it, the reaction that produces it itself, even if you make a 1% change in the efficiency of the process, you've just changed 1% of like a billion ton of CO2, okay? So it's not always what you think, right? I think maybe someone saw plastic bottles and they're like, the world is ending. No, it's really not. But we do have to be better about how we produce and how we reuse plastics in general, whether it's in textiles or in water bottles. Okay, so it's that. All right, that was a segue from more administrative stuff. Okay, there's a lot of text here, but what it says is please use the discussion board, which is what I've already mentioned. What we encourage you to do is discuss the strategy as opposed to what is the answer, right? What we encourage you to do is actually post the question, and then a TA, there will be a TA monitoring the discussion forum every day, and so your question will be answered within 24 to 36 hours, and the TA will most likely just answer in a sort of a general strategy, like this is how one would go about solving this problem, but will not outright just say, well, here's the answer, good luck. We want you to be able to apply the process elsewhere. And of course, if you post it and you said, oh, hey, is the answer this? That probably won't get you an answer, or you'll get a very polite email reminder that that's not appropriate for the discussion forum, and please reword your question, because we would like to answer it in a meaningful, useful way. Homework policy. So as I mentioned in your syllabus, it does outline the penalty for late submission. So you get deducted 40% for every day that it is late. We try to open it up with a lot of time so that you have sufficient time to finish your homework, and of course ask any questions you may have. Okay. In communications, this is a large class. However, we do want to respond to all of the questions that you have. First and foremost, try to email your TA. Your TA has a smaller subset of the class, and so they'll be able to get through your questions probably faster than I can. And so first try your TA, and then please contact the appropriate person for the question that you have. As I mentioned on the previous slide, if it's about Wiley Plus or something like that, please email Dr. Brown, and of course any other administrative stuff he will also take care of. And if there's any, if you'd like to discuss something private, please also email me and we'll make an appointment to do so. If it's that you can only meet during office hours, that's fine. I'll ask other students to just step outside if there happens to be other students that are there. So that's that. Okay, the exam. The exams will occur during the class time. There are 3 exams. Your final exam will be administered during the allocated final time, and that date is already posted in your syllabus. Once again, I reiterate, we will try to make accommodations for the events that have already been scheduled. We've been communicated in terms of athletic events. I think any traveling for any other team activities, and also any medical issues, we'll work with you to do that. And then if you can't make up the final exam, I believe within the final exam period, then you'll get an incomplete, and then we'll work with you and SLDS to establish a makeup date that is reasonable. Okay. And as I mentioned, we will work with you and SLDS to make any accommodations that you need. We'll be emailing all of you the information that we've received this morning from the SLDS office. And if you haven't heard from us by the end of this week, that means we didn't get a request from the office. And if you think we should have, please ping us. And by us, I mean Dr. Brown and myself, okay? I think it goes without saying, but I will remind you that we adhere to the academic integrity policies that are set by the university, right? I think at this point, you're fully formed human adults, so if it's dubious, if something is allowable, then it's probably not. And we outline very clearly what is allowed and what is not. Can you do homework in a group? Yes, obviously. But should you be the one putting in your answers and clicking the submit button? Absolutely. It should not be a colleague of yours, right? It should be you and yourself. And that obviously goes for other parts of the class as well. In terms of any issues with academic integrity, we, the instructors, fill out a report. We don't make the judgment, but we will fill it out and allow the committee on academic integrity to decide the course of action, okay? Okay. Places that are important on the internet for you. Carmen is an important place for you to know. Links for the homework as well as all of the lecture slides are there. If a link happens to be broken, if it's not working for whatever reason, in the past it's most likely been that permission settings were a little bit different. And so students weren't able to access. So we can solve that. Just please send us a nice, polite email saying, hey, did you know that this link is broken? And we'll get on it, okay? The other thing I want to note is, in the past, when we've linked PDF of the lecture slides as on Box, where we say only allow people from our network, which is OSU, there have been some glitches on iPads. Like if you access Carmen through the iPads, some students weren't able to access it. Just let us know, okay? Let's see, what else? Important announcements. We do the best that we can to stick to the schedule, but sometimes there have been snow days or very cold days. I think a lot of you remember the, what was it, the polar vortex from last semester, or no, two semesters ago. If there's a polar vortex, we'll let you know. We'll comply with university policy, okay? Obviously, nobody's expected to come to class in a polar vortex or anything else. If there's a snow day, we'll do our best to get the announcement out as soon as possible. And obviously, please check Carmen, and your email for all of these announcements. Let's see, grades. It should be in real time. Everything's already set up in Carmen. So as soon as you see that if there's a clerical error or anything like that, just alert us. We'll be happy to address that in a timely manner, okay? Everything is transparent. And then let's see, what else have I missed? Yes, your Wiley Plus. Why do you care to have it other than doing your homework? There are detailed tutorials. Obviously, your homework assignments are on there. The solutions will also be on there. Video solutions, your homework grades will be on there, and of course, Top Hat. Okay, let's see what else. Now, how am I structuring this class? Well, it is a large intro class, so that means a lot of you have different backgrounds in terms of education, familiarity with the material. This is the breakdown of the class right here. you could see that these are all the majors that are in this class right now. So we have almost, I think all engineering majors and some arts and sciences. The majority of you are mechanical engineering juniors. And in terms of the breakdown of the class, 60% of this class is mechanical. So I know you have gone through stress strain curves, right, in your intro classes. You're pretty familiar with that. The other 40% may not be. Okay, so we'll go over some of the basics of mechanical properties. And so if you think, wow, this is the nth time I've seen this stress strain curve, that's okay. It could be review for you. But for the other 40%, it is not review. It's new material. So, you know, bear with me on that. And the same goes for the biomedical students. And we're talking about biopolymers. It may be old news to you. Please use it as a review. The balance of the class, it could very well be very new material, okay? So there's a large intro class. Some of it will be new for you. Some of it might be not. And then the balance is materials, computer science, ECE, arts and sciences, and so on and so forth. And in terms of the breakdown of the class by year, you could see that an overwhelming majority are juniors and seniors, some sophomores as well, and only a very small fraction of you are year one students, or what OSU considers in terms of credit hours year one. So what this means to me is that you are very familiar with the OSU system, right? This is not your first time at the rodeo in terms of how to respectfully email professors, how to engage with TAs, how to develop skills for large lecture courses. You probably know what works for you at this point, okay? So that's what it means to me. Okay, with the remaining time, we're going to go just a little bit into materials itself. This will be the start. Who has seen these type of plots? Okay, I see two hands. I see a wavering of hands and a bunch back there. So where have you seen these plots? Feel free to shout. It's like an industrial engineering class. Okay, so industrial engineering class. What are these plots called? Okay, so you've seen it in industrial classes, okay? Any takers on the name of the plots? Well, Michael Ashby would be very offended. They're called Ashby plots, right? And so why are they useful to you? Because it's not often that you're only interested in one material or one material's property, right? You're interested in how to optimize your material for a number of things. Like if you think about, okay, not only do I want to increase the strength of the material for, let's say, an automotive chassis, you obviously could potentially want to lightweight the material because that means less gas in the car that's needed to go the same amount of distance, right? So you might want to lightweight the material as well as improve its strength at the same time. So these types of plots would be useful for you. They're called Ashby plots. And this particular set of materials properties plot in the y-axis strength versus density, right? And so over the years, you could see what I'm probably going to, you probably see where I'm trying to get to is like the materials that you have access to has really, the number of them have really exploded. So let's go over it. So in 50,000 BC, the Stone Age, right, you could see here that you basically just have natural materials, what you can get your hands on, what you can get from just the areas around you. So you got wood, grain. You could also mine for some gold, right? So it's high density and relatively high strength, okay? Oh, I should use my laser so you can see it. So yeah, so you can see here gold as a relatively high density, but if you want to lightweight, let's say you want to make something and you want to lightweight it, you might want to go for wood, right? These different types of wood. Almost comparable strength, but much lighter, right? You wouldn't be making a gold wagon or something. Well, okay, we're not in the wagon era just yet. Okay, so that was the Stone Age. Going to the Iron Age, Here you could see the densities of the green area, the yellow area, and the red areas are growing. Obviously, people are discovering more materials. There's some glasses and ceramics that are being made. There's same amount of leather, really. You still have access to the same natural materials, wood, grain, cork. And then there's more metals, as you can see here. There's tin, lead, copper, wrought iron, bronzes. So the number of materials that you have access to are growing. All right, now we get to the dark ages. The green, yellow, and red areas are growing. So strength versus density here. You could see more natural materials, glass and ceramics, more metals. Then we get to the age of steel. Okay. So this is, let's see. The Roman Empire was about this time, the Iron Age. Then you get to the Dark Ages, then you get steel. Okay, now this is where it gets interesting. You could see ceramics, still this sliver, but you could see the amount of metal and alloys have grown immensely. The red area has grown immensely. So now you see things like zinc and cast irons and steels, very important for industrial manufacturing. And then what you should also see around the 1900s is the invention, the start of the plastics era, but you'll see that more here. So you see now there's this blue area, there's bakelite, epoxies, acrylic. Okay, so really the first patent for what would be considered as like the polymer industry really started late 1800s, and then around 1900s or so, you got plastic formation from casein, so proteins. We'll talk about how proteins can also be polymers. So really here you see an explosion with polymer products. Still natural products exist, and then metals just become larger and larger in area. And then present day. So now you can see there's a major jump from 50,000 BC to basically between 1945 and present day. So you see here just a lot. And so this is an exciting time to be studying material science, because what you have access to you in terms of not only structural materials but all sorts of materials properties is enormous. But what that also means is we have the task to be responsible with the materials that we produce. Because as you know, as I think the majority of you voted, that plastics contribute to a lot of CO2 emission, and that is absolutely true. Does it necessarily have to be quote unquote bad? No, if we can engineer more efficient production methods and also recycling methods, right? So material science is really about optimization, right? And not just getting rid of materials, okay? So it's a really exciting time. And here's the evolution of materials over time, well, even to 2020, although this plot was produced a few years ago, so they were obviously extrapolating. But you could see here, right, that metals, polymers, composites, the distribution has really changed. People were focused a lot on metals, in 1940s, 1960s, but now that's sort of decayed off a little bit. And so there's a lot of work today and going forward in terms of developing efficient synthetic procedures and also reuse methodologies so that we can more reduce the carbon emissions from the production and usage of these materials. So sustainability is a very important concern, issue in dealing with all of these materials and engineering their uses. Okay, so obviously I don't think I have to tell you that materials is everywhere, and obviously it affects our everyday life, right? And making a small percentage change in how we use them, how we process materials, all of that is dramatic. Okay, so if you think about ceramic materials for batteries, right? if you make a 0.1% change in the efficiency of a battery cathode material, you will have affected everybody with an iPhone, with a heart implant, how many years they have to go before they have to deal with another surgery to take the battery out and put a new one in, right? You affect everything from just engineering to the biomedical applications itself. So what I would hope that you get out from this class is not only understanding the basic properties and basic concepts and terminology material, but also how to take the next step and think about, well, what can I do in my respective major, in my respective field, to make a material selection decision to make the process either more efficient or sustainable in whatever it is that you do. I don't think the Kodak company saw this coming, right? But certainly the materials revolution has aided a lot of the technological advancements that you have right now, and it's all embedded and integrated in devices that you think, well, how effective or how impactful is material selection there, right? So before it used to be that you had these clunky like plastic or big cell phones. Now you have these indium titanium oxide glasses with aluminum bodies, so it's lightweight. You're not carrying around this heavy mobile device, and on top of that, it's crack resistant. So we'll talk about Gorilla Glass and how to make that, how one change in an ion selection with a small percentage going from sodium to potassium has basically changed how often you go to the Apple store to change your cracked screens, right? I think a lot of you have experienced fewer cracked screens because of this Gorilla Glass, right? So glass can be tough and can be engineered to be tougher. But beyond, just day-to-day, will my device last longer or will it shatter? There are actual wide-reaching applications, and we'll talk about how understanding a material's property over different ranges, like different temperature ranges, and over time can actually be quite impactful. So we'll talk about brittle to ductile transition and how not doing materials testing under realistic conditions can have really drastic consequences. So this ship, so it was in the cold Atlantic Ocean. So if it weren't for the fact that it ran into an iceberg, there could be other drastic failures, such as when metals experience temperatures below their brittle to ductile transition temperature, they can fracture quite easily. So I don't know if any of you have seen, when you stick something in liquid nitrogen, you take it out, it was floppy before, and then it shatters everywhere. Has anybody seen that? Okay, some of you, thank you. That is an analog to these types of fractures, right? It's strong, the metal is strong, and then it goes below the brittle ductile transition temperature, and it can experience really dramatic fractures. Okay, let's see. We'll also talk about engineering and learn from engineering failures of the past. This plane is an example of why you don't build airplanes with square windows. So we'll talk about fracture points there. So with that, I'll leave you with the last slide in terms of takeaway messages. Please get your reading in chapters 1 and 2, and then your homework will be due January 17th. There's no recitations this week or office hours. Those start next week.